For perfect problem 3 for math, what is this, 243? And what we're doing is we're examining the correlation between how much money a baseball team spends and how many wins they got that season. So what we want to do first is create a scatter plot. So I guess the first thing you got to do is figure out what your explanatory variable is and what your response variable is. Cause and effect. In this case, the explanatory variable, which we use x to represent, is how much money you spent, because how much money you spend might cause you to win more or less games, but not the other way around. You spend the money first. In case that was a little unclear, I worded it pretty clearly up here to determine if spending money leads to more wins, cause, effect. So the first thing was a scatter plot. It's going to not be the most fun thing in the world because we have so much data, but I guess we can do it. So you want to put all your data into lists. I went ahead and did that before I started the video because I didn't think you wanted to watch me type in all those numbers. I got my x variables in L1 and my y variables in L2. And now that I've done that, I can go up to stat plot here. I want to first I didn't want it to graph this line. This was from a different problem. So I'm going to go up to stat plot, plots on, create my scatter plot. L1, L2, mark, that all looks great. I'll zoom stat, and what I'll get is a scatter plot. A lot of data in there. So what it wants me to do is create a scatter plot, make sure to properly identify your explanatory and response variables, label the data point that represent the Oakland A's because they're awesome. I'm gonna guess that's it. So what you want to do is copy this thing down. I wonder if there's a way for me to copy that as a picture. Bet there is. And then just put it straight in here. Man, that'd be nice. I'm going to do that. I'm going to figure it. So here's the answer, this thing. I guess I should. I'm just going to draw it. Alright. Guess if I'm making you do it, I shouldn't groan so much about doing it. So this is my X. This is payroll. And it's in millions. Millions of dollars if you want to be exact. And this is wins. And let's see, wins go from the worst team won, what, like 60 or so games? There's 67 out of Seattle. There are 56 out of Houston. Yeah, that's probably the worst. So I'm going to start here at 50. Best teams won, what, 102 I think was the most that year? Philly. They're terrible now. Maybe not terrible, but not good. I'll count up by increments of 10, making this 100 up top. And then for payroll, it looks like the least was 55 by my beloved Oakland A's, and the most was 198 out of the Yankees. So I'm going to start with 50 over here too, and I guess since I'm starting at 50s, I'll put a little squiggly line there to emphasize that I'm not starting at zeros. And I want to go up to 200, so I don't know, 50, 100, 150, 200, sure. Then I want to put a dot down for each of these. So the A's spent $55 million and they won 74 games. It's not that great. They're a lot better now. But whatever, that would be somewhere in here. And I think it says to identify which point represents the A's because I love the A's. So I'm even going to label this one Oakland A's. And then I'm going to go through and put all the rest of the dots in. So like 55, 71. Don't worry, I won't make you watch me do the whole thing. I'll put this video on pause and put in all these different dots. Maybe, yeah. So I'll be back in a minute. Alright, there's all my dots. There should be a dot representing each of these data points. It's very approximate, but you will notice that this kind of looks like this. More or less has the same shape. And I think that's everything that I had to do for that one. Create a scatter plot, make sure to properly identify your explanatory and response variables. I got that. Label the data point that represents the A's because they're awesome. That's true. Find the equation of the least squared regression line, then draw it on your scatter plot, and interpret the coefficients. Okay, the way we can do that is back over here on our calculator. If you go to stat, and then calc, and then linear regression, and tell it your x variables, mine are in L1, comma, your y variables, mine are in L2. It'll calculate a lot of stuff for you. Probably the most important thing that it calculates for you is this least squared regression line. Maybe I should change color. In this case, it's y hat equals A, so 0.189. Wait, 0.19 x plus, I'm going to do 0.188. I might as well show more decimal places, and then if you round, you'll be able to tell if the answer's right. 0.188x plus 62.5. There's your least squared regression line. If you want to see it on the scatter plot, you can either just try to draw it freehand, or you can go into y equals here and type it in. So 0.188x plus 62.5. If I graph that, it redraws my scatter plot, but now with the least squared regression line through it. So what I can do is I'll jump over to my line here. So my line has a height of approximately 72 when the x value is 50. So let's see, 50, 67, my line will be going kind of through this point. And then it also has a height of, well, I guess I could go from the slope. The slope is 0.188, so if I go up 100, that thing's going to go up 18.8. This far, I'll just let the trace do it for me. Go over to 200, approximately. There's about 200, and the y should be about 100. So 200, 100 is this point here. So I'm going to try my best to draw a line that goes through those 2 points. Yeah, that's not bad. Hard to draw a straight line on a computer, but that's pretty good. There's my least squared regression line. Cool, did it. Comment on, oh no, interpret the coefficients. All right, so the 0.188, well, let's start with the 62.5. That's easier to talk about. The 62.5 means that if you spend no money on your team, you get a bunch of volunteers out there playing, you'd expect to win 62.5 games. The y-intercept here is kind of out of the context of the model, so the y-intercept doesn't really make sense in the context of this problem, but this is what it would mean. Kind of funny when you consider that the Minnesota Twins won 63 games that year. They spent $94 million to win 63 games. This model is saying spend nothing, you'll win 62.5. So in other words, it's saying the Minnesota Twins were pretty terrible. Yeah, I think that. Oh no, even worse. The Houston Astros, 56 wins. There you go. Spend no money, you should win 62. The Astros spent money and they only won 56. Sucks to be an Astro. 0.188 means that for every additional 100 mil, no, 1 mil, every additional $1 million, you win 0.188 more games. In other words, wins are hard to come by. They're expensive to buy wins. Did that. Comment on the type and strength of correlation exhibited. Use your correlation coefficient as justification. So my correlation coefficient, R, is equal to 0.608, 0.61. So I would say that, maybe I can do that up here. It looks like weak, or relatively weak, moderately weak. How about that? Moderately weak, positive correlation. Then I'll say R equals 0.61. So positive because it's a positive number, but moderately weak because this isn't that close to 1. 0.6. Kind of close, but not that close. Write one sentence what R squared tells you. That's not English. Whatever. R squared is 0.37. So 37% of the variance in wins is explained by payroll. This whole paragraph, this kind of stupid paragraph, is just saying how many wins would you expect to get if you spent 100 million? We can figure that out because we have this least squared regression equation that tells me how many wins I would expect for any amount that I spent. So in this case, y hat would be 0.188, not times x, but instead by 100 because I'm spending 100 million plus 62.5. 0.188 times 100 is 18.8. 18.8 plus 62.5 is 80.81.3, I believe. All right, this is 18.8. It gets me to 81.3, yeah. How many games? I'd expect to win 81.3 games if I spent 100 mil. Bonus question. So you didn't have to do this, but you can. It says the record for most regular season wins is 116. How much should a team spend if they expect to win 116 games? So this is kind of tricky. I'm telling you the answer. I'm telling you the expectation. Maybe we'll go somewhere else. How about down here? I'm telling you that when you use your least squared regression equation, 0.188x plus 62.5, the answer you get is 116. What I'm asking you to figure out is what must x have been. So if algebra is your thing, you could subtract 62.5 from both sides of this equation. You could say 116 minus 62.5 is equal to 53.5. And so if you divide 53.5 by 0.188, you get a huge number. You get 284, say approximately 284.6. So spend $284,600,000 and you'll expect to win 116 games. 116? Yeah, 116. A lot of money. This was just bonus. You didn't have to do this. But there you go. There's the answer, and I guess that's the end of this example.